Supercharged by countless successes in the motorsport, Audi has always honed its Vorsprung at permanent all-wheel drive and developed it still further and thus maintained its lead. But now, let's have a look at some of these milestones. At the very start, the objective of development was all about traction, clearly. Then in the 2000s, drive dynamics came into focus. Both traction as well as drive dynamics were then ultimately to be combined in the efficiency topic. Well, dear colleagues, as always, our Tech Talk is split up into two parts. In the first 25 minutes, roughly, we'll give you an overview and an insight into how we have honed our permanent all-wheel drive system over the years, all the way through to Quattro Ultra. And then we will also address the question, what's the potential that Quattro has in electric mobility? This is followed by a Q&A session where we look forward to chatting directly with you. So you can use already during the presentation the chat function to send in your questions during that first part. So write in and we will come back to these questions later. Otherwise, we would like to hear directly from you in audio and video signal, so you will live here with us in the studio. So, how do we manage, at the end of the day, to have our permanent all-wheel drive system fitted to utmost efficiency? And the answer to this comes from Dieter Weidemann. Hello, Dieter. Well, the advantages of Quattro are obvious. You have excellent traction, you have enormous drive dynamics, and you always have utmost safety and security, and that for 365 days a year, no matter what the weather conditions are. So, what was ultimately the reason to develop the Quattro Ultra technology? Well, a number of years ago, we conducted a major customer survey with thousands of customers, and we asked, especially those who had not yet decided to buy a Quattro. So, these were actually the customers who bought Audis as well as competitor cars. And with them, we looked at all-wheel drive train systems, and what we found was that with many of them, the advantages that an all-wheel drive train offers were not known by most of these customers. And often these were also customers that had never actually driven in a Quattro, an all-wheel powered car, and just, well, reached everything that they wanted to reach with a single powered axle. And they didn't know what the added value of all-wheel drive trains was because they never experienced it. And by the same token, a consistent answer was also that they felt, well, Quattro all-wheel drive trains would take up extra fuel. Now, often, people could actually not pinpoint this precisely and say how much more fuel they would consume. Sometimes it was absurdly numbers that they thought, well, it's a substantial extra amount from fuel, but no, it's not really. But in the combination, they can't see the advantage, but they only see the so-called efficiency disadvantage as they perceived, and thus did not go for a Quattro. So for us, the development target was, we wanted to develop a Quattro powertrain that offers you all the advantages of a permanent all-wheel driven car, the full performance, but at the same time, these little extra consumptions are reduced to an absolute minimum. That's what we call Ultra. Does it then also mean that efficiency never played a role in your development work? Nah, you can't say that, says Dieter, because also with the all-wheel drive train, which we've developed and honed over years, efficiency is, of course, a vitally important measure. I mean, there's countless efforts we've taken, for example, here, reducing the oil consumption on the rear drivetrain and optimized bearing and the likes, where we really made sure that we wanted to bring down friction. But, of course, there's physical limits that you come to, where you find that the iterations you are taking are no longer in correspondence to the effort you have to take. And then, of course, you have to switch technology altogether. And if you really take a step towards extra efficiency, well, then you have to look at an all-wheel drive system that can be deactivated, as we've done with Quattro Ultra. So what were the technical challenges in the development of Quattro Ultra? Oh, there were quite a few. Now, the biggest objective, that was, shall I say, the superimposed target, that Quattro Ultra should be a fully fledged Quattro. So no drive situation should you notice a difference between an Ultra and a Quattro Ultra, between a permanent all-wheel drive system and a Quattro Ultra. So the customer is buying a Quattro from Audi, and that's a legacy that we really want to keep clean and foster. And so that was the biggest challenge for us, that in all drive situations, the difference is noticeable that you are driving a Quattro. And then, of course, there's technical challenges as well, which I can show you here with this cutaway model of the drivetrain. Because we've decided to go for a solution with a multi-plate clutch at the end of the transmission, and on top of that, as you see here, a separator clutch at the rear axle drive. Now, to really pay into efficiency, you have to know exactly where are the sections where you incur, so to say, losses. And almost 80% of any drag losses are to be found on the rear axle drive. Namely, it's the crown gear here that is, so to say, sloshing through the oil, but also, of course, the bearing of the pinion shaft and the casing. That's the main loss drivers. And if I want to achieve anything for efficiency, I need to make sure that the crown gear and that the pinion shaft are dormant, come to a standstill. So if I only have a multi-plate clutch, I may be able to open it and then don't transfer torque to the rear axle drive, but still, everything keeps moving, of course, simply by the wheels. They will be carried along, which means you incur drag losses. So what you need is a second clutch. That's a separator, as we call it, a separator clutch here on the rear axle drive, which if we open it, and if it's no longer powered from the front, then, of course, all the components that are powered can really become dormant. And with that, we can achieve that maximum efficiency. So you say it's a second clutch, an added component. I mean, an added component normally means extra weight, no? Yes, of course, but there's also counterbalancing effects. Simply by giving the multi-plate clutch here and installing it, we can also reduce here, so to say, the peak torques on the rear axle drive, which gives us the possibility to build all these components on the rear axle drive, well, one whole unit smaller. So although we've got extra efficiency in Quattro Ultra, in sum total, we actually have less weight. Well, can you give us concrete figures for this? Well, it's a bit dependent, of course, on the rear axle setup and the deployment. It's anywhere between 3 to 5 kilograms that the Quattro Ultra is lighter than the standard Quattro. Now, moving a bit from the technology to the operating mode, and let's have a look at this technical animation. Dieter, talk us through it, please. Indeed, gladly. So what you can see, if you don't quite know, or after getting started the car, you will always be in all-wheel drive mode. And in situations where you're 100% certain there's no difference, you can go and switch to front-wheel drive mode. So the philosophy is different than you would think, namely other producers that have principally a front-wheel drive system, and if they need, they switch to all-wheel drive. No, we always have the all-wheel drive system activated first, and especially on poor road conditions, if we detect that, and if we have high torques, then the customer has always the all-wheel drive system activated. And of course, this has to happen at lightning speed and unnoticeable for the driver. So you don't, as a driver, notice whether it's front-wheel drive or all-wheel drive mode. That's not something you can discern. How we've done technically, here, you can see it now in the following animation. If we're switching to front-wheel drive mode, first of all, we actually deactivate the multi-plate clutch, and so no torque is transmitted to the rear axle, which then means we can now open the claw clutch at the rear. At the same time, while we open that, we're pre-tensioning the springs that you see nicely here in red at the top of the claw clutch, which means I've got a pre-tensed system, which is much like a gun that is just waiting for the trigger to be activated, because of course it's vitally important that if need be, it can be activated at lightning speed. Anything that's green now here is actually dormant and at standstill. Now, if there's a situation where we need all-wheel drive mode again, then we synchronize the dormant parts, first of all, to swing in again with the all-wheel clutch, and then at lightning speed, activate the claw clutch. And as you can see here then, well, from all the components that we're looking at, this is geared to maximum reactivation speed. And of course, well, yeah, deactivating can take any time we need. There's no need to do that speed, that disconnect, but the reconnecting, that needs to happen at lightning speed. And also in any interim status, especially when we sort of activate, then we must be able to reactivate the claw clutch at lightning speed, as I say, to have the all-wheel drive system quickly reactivated. And we're talking here at anywhere about 200 milliseconds as reactivated. So super fast, and it's a very nifty system that you developed here, I must say. So what's the benefit for the customer? Well, the benefit for the customer is, of course, he gets a fully fledged all-wheel drive train system. He will notice nothing of the change between 2- and 4-wheel drive. He's got all the advantages of all-wheel drive trains, and he only has a very limited extra fuel consumption. Well, let's have a look at a concrete example here. During a press event south of Munich, we had a car and had it given to two journalists. Of course, all of this happened some time ago, well before the corona crisis. And the car was fitted to the rim with measuring equipment to record the drive behavior. So we really monitored very precisely how much are they driving in four-wheel and how much are they driving two-wheel drive mode. How often is it activated and deactivated? And what kind of driver types are these two journalists? Now, Dieter, what can you tell me from what you see here, that evaluation, that graphic evaluation? Well, so Dieter, if you take a look at that route that we've driven, it's, well, roughly 40 kilometers in length, the total distance, and you can see anything that's given in green is the shares where you drive just in front-wheel drive mode. And everything in red, that's where you have four-wheel drive mode. Now, on the left, starting from start-finish, you can see this is just a very normal standard driver, the way you would experience it in customer situations. There's countless situations where all-wheel offers you an advantage, and thus it will be activated, but only for very short periods. For example, if you leave that situation again, and if you're back to sort of coasting constantly, you won't notice the difference, and you are back into front-wheel drive mode. That's the efficiency mode. Now, there was a driver change, as you see, and then the next colleague was quite a different character, and he quite deliberately wanted to test the system and bring it to its limits, or, I mean, yeah, he was trying to really to play it out, but he wanted to achieve states where he would felt the front wheels would encounter slippage, as he imagined, and he went, as I said, to the limits and was very dynamic in his interactions with the car, which of course means, as you see, a great share of his drive was in all-wheel drive mode. After he, tried for a while, I never really managed to outplay and outtrick the system. He gave up and tired of it, as you can see, and became what we would call a classic, a normal driver, and was then quite convinced of the performance of the system. Meaning it's a self-learning system? Yes, indeed. It learns a lot, that system. It learns, for once, how the driver interacts with the vehicle, but also there's other learning functions installed in the system, because, of course, also conditions in the car can change. For example, if I've got summer tires and switch to winter tires, I've got a completely different slippage coefficient, something the system will learn. Then also the components that are individually fitted to a given car, of course, have different friction ratings, and they will also be learned. So every time we deactivate, we were looking at the gradients. So there is plenty of learning functions that are constantly optimized as we talk, and so that activation and deactivation, improves time and again. What's the role of networking the different systems within the Quattro powertrain? Oh, that's vitally important, says Dieter, because, of course, to assess the situation correctly, we're very much dependent on having a good situation detection, which means plenty of data goes to and fro between the different control units. I mean, we've got our own independent control unit here, the Quattro control unit, but we're constantly in contact, in communication with the engine control unit, the ESC, the drive select, and the likes, and thus have access to all the data coming from the sensors. In flex rate, that's in every 10 milliseconds, we exchange 150 data ratings. And with that, of course, we can get a pretty rounded picture of the drive situation the car's in. So with the system Quattro Ultra, we've only got one additional sensor fitted to the system, and that's the at the start of the rear axle drive, the speed sensor, and just to make sure that you have the right speed sensor activated. And everything else, of course, are already a given in the car. No need for extras, but of course, we simply use different algorithms to evaluate them. Meaning the degree of networking, of course, really went up with the introduction of the Audi e-tron models. Now, what I mean by saying that is something I hand over to my colleague Mark Bauer, who is responsible for the chassis development of the e-tron S, and he's with my colleague Susanne Melikov in the other studio. So over to you, Susan. Well, thanks, Eva. Behind the electric powertrain, we find the intelligent networking of a host of different control units. So, Mark, tell us, how do you get the Quattro fit for the electric world? Well, look, you already said the key word. It's all a matter of networking. And with the electric Quattro, you will find there's no mechanical all-wheel system anymore, like a self-locking mid-diff, no mechanical element, or a clutch, as you know from a Quattro Ultra, no. That functionality, and above all, that emotionality of the Quattro powertrain is simply achieved by functional software over interlinked and networked control units. And here, the electric motors, of course, pose their own challenges, but nonetheless, they also offer us a huge advantage when it comes to spontaneity and speed of all-wheel control. And to speak of concrete figures here, it takes a mere 30 milliseconds until we have the torque moments between front and rear axle distributed. And that is a lot faster than any mechatronic system can cope with. And the benefit for the customer is, of course, it's quite a unique, dosable powertrain, drivetrain, and also an uncomparable traction in our e-tron models. Well then, let's have a look at our e-tron S model, the latest addition to the e-tron family. Next to the big electric motor at the front axle, two independent electric motors are working on the rear axle, which means the car has an absolute USP when it comes to drive dynamics, namely the electric torque vectoring, which of course is added to the electric quattro. So tell us, how does that really work and what the ECP plays here? Yes, glad. Let's have a look at the rear axle in detail. In the e-tron S, you will find we've got two electric motors to the rear axle, and these two each clock up over 300 newton meters of torque, which in sum total means over 5,600 newton meters of torque on the wheels, wheel torque. Now, technically demanding is, of course, the design. You can see two separate rotor and stators here, and the two separate power electronics, all fitted into one casing, though. Now, the two electric motors, they act quite independently respective of one another, and there's no mechanical connection between the left and the right wheel, as you would know from conventional combustion engine cars. And now the diff that we have here is simply, well, replaced by software. And in this case, it's not an open diff that we replaced. No, we've also made sure that the functionality of a controlled rear axle lock and a sport differential can all be provided by the system. Now, back to your question, the electronic chassis platform, the ECP, plays, of course, a vital role in all this, because it's like the heart of our integrated latitudinal and longitudinal torque distribution. And it controls and manages the electric torque distribution between front and rear axle, the wheel selective torque vectoring between front and rear, and the wheels, and also the electric torque vectoring at the rear axle. Now, torque vectoring is something I'm sure most of you will have heard of, but could you just give us, shall we say, an idea what it really means? Oh yes, there's a pretty good analogy for this, by the way. Just imagine sitting in a rowing boat. Now, if you row, you use your muscle power to, well, operate the oars left and right, and thus keep the boat or the vessel going. Or what you can do, you can apply a little more force left or right, and this way you bring the boat, the vessel, to steer in. But of course, he doesn't have to add extra force. He simply distributes it differently, and that's exactly what torque vectoring also does. Question is about, as is electric torque vectoring, as this not only is a plus in drive dynamics, but also in traction. Well, you've given us a clip before the show, did you?
We are here now at the Audi Driving Experience Center in Neuburg, and we're using our proving ground to show you the technology of electric torque vectoring. In electric torque vectoring, we are not only able to improve the vehicle's agility, moreover, we have the possibility to set a new benchmark regarding traction and vehicle stability. In an open differential, the torque of the wheel with the lower friction determines the force that is applied to the other wheel. On the rear axle, where we don't have this mechanical connection between the left and the right rear wheel, we can totally independent shift the torque and use the maximum of traction for the driver. Yeah, we're just using the track to show you how the technology works. That function can be applied directly to normal road surfaces. Imagine a very icy road, imagine a wet road. Electric torque vectoring always gives you a maximum of traction and stability in every situation. So let's take a deeper look how that works in reality. Therefore, we are here on our track, on our off-road parcours. And if we look on the front axle, we see the wheel with the open differential, it's just spinning. Now let's take a deeper look on the rear axle, which is very interesting. Electric torque vectoring helps us. The wheel is standing, you're shifting all the torque to the other side, which gives the customer a maximum of traction, and that is quattro.
Well then, in summary, thanks to the twin engine on the rear axle, we no longer have to decide between a sports diff or a controlled interwheel diff lock. With electric torque vectoring, we combine the advantages of both systems in one drivetrain concept. Exactly, that's how it is with the two electric motors on the rear axle and the, well, no longer mechanical connection. We've got complete new leeways in how we distribute lateral forces and torques. And this allows us to give you an extra in drive dynamics, driving fun, and also driving safety. And the customer will experience this not just, shall we say, at the physical limits of the car, but he will notice this and will experience this at every steer-in, at every roundabout, at every situation he's in, with the excellent traction of, well, different friction ratings on a wet road, for example. Well, thanks, Mark. You may already join the others. Dieter for the Q&A round, and I say goodbye and hand back now to Yves. Well, dear colleagues, as always, you will have received ahead of your slot with all the materials in the press kit, with the text, the illustrations, the animations, and the clips. So you can see, colleagues, Quattro for us at Audi is far more than just an all-wheel philosophy. It is Vorsprung back then, today, and also in the future. So thank you very much for tuning in. Thank you for listening, and thank you to Dieter and Mark for your time. Stay tuned and stay with us at one of our next Tech Talks, where it's all about Formula E, and also, befitting the time and season, it will all be looking at light technologies. So